Hi everyone, hopefully you have out the note sheet that I gave you in class, which says section 6.2 day 2 on top. If not, make sure you have it out. Go ahead and write the target down, which is simplifying radical expressions. And the reason I'm doing this video is this section tends to be one that's a little bit tougher for students. So my goal in this, I'm just going to work through a few just random problems here. I think I'm going to do 4 of them so that you can have somewhat of an understanding before getting to class, and then we can keep working on that and go further in class, and then give you some time to start working on the homework, which I think is the time that you really get to ask questions and give yourself a strong understanding. So some of this will seem familiar to what we worked with last semester when, if I gave you, let's say, a problem like the square root of 32 and I asked you to simplify that, and you would go through that list of perfect squares there and you would think, okay, does 4 go into it, does 9 go into it, does 16 go into it, 25 all the way up, and you would look for the largest perfect square that went into it evenly, which in this case is 16, and then we could split that radical up and make it square root of 16, square root of 2 using the product property, and we'll talk about that in a second, but square root of 16 is 4, and then we would simplify that to 4 square root 2. Something like the square root of 10, that would be as simplified as you could go because 4 doesn't go into it, 9 doesn't go into it, and then it gets too big after that. So we are going to still work with that property, but it does get a little bit more involved when we start working with cube roots, fourth roots, and things like that. The chart that I gave you here, well, let's actually first look at this box right here. And this just says that if you have something that can be broken down into factors, you can split those up as 2 different radicals. So that's the concept here of saying, okay, if we have the square root of 32, we can split that up as the square root of 16, square root of 2, and then break it down further from there. In the chart that I gave you right here, this is just talking about, okay, if your degree is 2, you're going to be working with that list of numbers, which should look familiar as your perfect squares. If we're working with a degree 3, we're going to be looking at, or a cube root, something like that. We're going to be working with that list of numbers. Those are the perfect cubes, 2 cubed, 3 cubed, 4 cubed, and same thing with 4th root and 5th root. So the first question that I want to do with you is number 1, and first thing we need to notice here is that we are working with a cube root, which means we do not want to be thinking about 4, 9, 16 because those are perfect squares. We want to be focused on this list right here. And so I'm just going to write a couple of those at the top here. So we've got 8, 27, 64, 125, and then they go on from there. So just like we thought about with the square root of 32, we were looking for the largest perfect square that went into that. Now we're going to be looking for the largest perfect cube that would go into 135 if it exists. Now, some of these, the numbers that you're going to see on the quiz and the test, they're not, if you don't have a calculator, they're not going to be too bad. But first of all, if we look at 8 here, right away you should know 8 is not going to go into 135 because 135 is an odd number. If you wanted to kind of double check without a calculator, you could always do long division here, and it goes in 1 time 8, 55. It goes into 55 6 times, and you would have a remainder of 7, so that's not going to work for us. The next one, so 8 is out, that doesn't work. Then we'll check 27, and if you do go through 27, it does go into 135. It goes in 5 times. If we keep going, 64 is not going to go in because it's an odd number, and then 125 doesn't go in, and then you're going to get too big. So we are going to be working with this 27 right here, and just like we did when I showed you the square root of 32 on the first page, we're going to split this up as the cube root of 27 times the cube root of 5. The reason we're doing that is 27 is a perfect cube, the cube root of 27 is 3, and then I would still be left with the cube root of 5. And that would be your answer completely simplified for that one. So we got the largest perfect cube out of it. We simplified that as far as we could. Nothing we can do with 5. There's no more perfect cubes that go into it. And one thing that I just want to point out, make sure I can really tell what your number is that's in front and what your root is there. So make sure you write that number really tiny. Sometimes it gets a little mixed up. Okay, let's take a look now at number 4. So skip 2 and 3, we'll do those together. We now have to be working with variables. So we're going to do the same type of thing with the number, but we'll be working with those variables as well. So again, looking at our list of perfect cubes, that's what we want to work with. We've got 8, 27, 64, ... Well, this is really nice because 64 already is a perfect cube, so I don't need to split it up at all. I know that the cube root of 64 is 4, and I can just bring that out right away. Now, with y to the 6th, this is the part that sometimes takes a little bit of time for students to get comfortable with. I'll show you why it works, and then I'll show you the shortcut in a second. So if we're looking at y to the 6th power, cube root means we want to find something that if we multiplied by itself 3 times, we would get y to the 6th. Well, if you kind of think about taking 6 and dividing it into 3 groups, we would get y squared times y squared times y squared. Okay, and that's the exact same thing as y to the 6th. So the term that we can multiply by itself 3 times to get y to the 6th is y squared, which means that the cube root of y to the 6th is y squared. And that's actually going to be our answer. Now, we'll do many more examples of these, both a couple on the video and then a lot more in class. The shortcut that you'll start to be able to use is you're going to take this exponent and divide it by that exponent. Now, sometimes it's not going to divide evenly, and we'll have to talk about what to do with that. But this one works out nicely that 6 divided by 3 is 2. And the reason it works is you're breaking it up into groups like that. Okay, the third problem I want to do together is question number 5. And this one you can kind of tell is quite a bit more complicated. Now, first thing, we're working with a 5th root. So going back to that first slide here, we're going to be looking at those numbers right there. The nice thing when you get up to 4th roots and 5th roots, there's not a whole lot of numbers that you need to think about. And working with 64, really our only option here is 32. And 32 does go into 64, so we'll work with that. Now, what I'm going to do here is we're going to split this up into 2 perfect fifths. And you'll kind of see what I'm doing here as we go through it, but in the first radical, I'm going to put all of the things that will be perfect fifths. So because I just talked about how 32 goes into 64, I'm going to put 32 in the first one, and then it's 32 times 2 is 64. So all I've done right then is kind of split up that 64 into 32 and 2. Now, looking at these exponents, it doesn't work as nicely as the last one did because you can't do 8 divided by 5 and have it come out nicely. So what we're doing is we're looking for groups of 5 that would go into 8, and you'll see why this is going to help us in a second. But, so if you think about 8, 5 doesn't go into 8, it doesn't go into 7, it doesn't go into 6, but it does go into 5. So I'm going to split up this x to the 8th, and I'm going to put 5 of them in the first one, and then 3 of them in the second one. So we still have our 8, but we split it up into the biggest number that 5 is going to go into. Okay, moving on to the y's, we're going to be doing the same thing here. Looking, 14, 5 does not go into that evenly, so if you kind of work your way down and find the next biggest number. So with 14, if you go 13, 12, 11, 10, 5 does go into 10. So I'm going to split this up and put y to the 10th here. And then if we need 14 in total, if I put 10 of them in the first, I'm going to have 4 left over right here. And then we're going to move on to the z's, and I have 5 of them. The nice thing is 5 goes into 5. I don't need to split it up at all, so I'm going to leave all of those z to the 5th right there. Okay, once you do that, you should be able to take this first radical and totally simplify it and get rid of the radical. So if we look at the 5th root of 32 is 2. And then again, you can use the shortcut here, but the reason it works, if we're looking at the 5th root of x to the 5th, we're looking for what could you multiply by itself 5 times to get x to the 5th, and the answer would be just x to the 1st, and if you do 5 divided by 5, you get that. Then if we look at y to the 10th, 10 divided by 5 is 2, and it would be y squared, and again, If you do y squared times y squared 5 times, you would get y to the 10th. And then z to the 5th, if we divide the exponents there, 5 divided by 5 gives me z to the 1st. If you've done it correctly, that will all simplify, and then this will all have to stay inside the radical. So this would all be followed by the 5th root of 2x cubed y to the 4th. And that would be your final answer. Okay, one more, and then we'll finish the rest of this in class. And I want to do number 7. So we're working with cube roots here, so those numbers that we want to be thinking about are 8, 27, etc., etc. But because we've got a 6 in there, 8 doesn't go into it, and none of the other numbers are going to go into it. So when we go ahead and split this up into 2 perfect cubes, the 6 is going to have to stay exactly where it is, and it's going to have to stay inside. We can't split it up at all. But now looking at the exponents, if we have x to the 4th, we can split that up, and again, you want the biggest number less than that 3 would go into, which would be x to the 3rd, and that would leave us with 1x in the second one. Y to the 9th, 9 divided by 3 does go in evenly, so we can leave y to the 9th right there. And then with 14, 3 doesn't go into it, but you can drop it down to 12, and it would work, so you would get z to the 12th, and then we would have 2 of them left here. So then we're going to work on simplifying this. So 3 divided by 3 would be x to the 1st. 9 divided by 3 would be y to the 3rd. 12 divided by 3 would be z to the 4th. And then this part will have to stay exactly the way it is. So you would have the cube root of 6x and then z squared. So again, just bring this to class. We'll keep working on them, go through several more examples, and you'll have plenty of time to ask questions. Thanks.